Okay, so let's talk about average rate of change. Now let's take the parent function y equals x cubed as shown here on this graph, and let's take two arbitrary points on there. So let's just take the origin, so x equals 0, and then let's say x equals 1, which notice that on this graph 1 is in the middle because it goes from 0 to 2 to 4, so 1's right here. So let's take the point x equals 1, so right there. And we want to figure out what is the average rate of change between those 2 points for y equals x cubed. Now before I give you some arbitrary formula and tell you where to plug numbers into, let's try to understand what average rate of change even means. So let's say you're driving from Kansas City and you're going to Denver. So you're driving west on Interstate 70. And generally speaking, it takes about 8 hours to make that trip. So let's say that for the first 4 hours, you decide that you're going to drive 100 miles an hour. So the first 4 hours that you're driving to Denver, you're going 100 miles an hour the entire time. And then let's say immediately at hour 4, you decide you want to drive 60 miles an hour. So from hour 4 to hour 8, you drive 60 miles an hour the rest of the way before you get to Denver. Now, if someone was calculating the average rate of change of your trip, they would take the 100 miles an hour you were driving for the first 4 hours, and they would take the 60 miles an hour you were driving for the last 4 hours of your trip, and average those two speeds together, which would give you 80 miles an hour. And the assumption that the average rate of change would tell you is that it would assume that you were driving 80 miles an hour for the entire duration of the trip. So even though you were never really driving 80 miles an hour, if someone called you at hour 2 and said, "Hey, how fast are you going?" you would say, "Hey, I'm driving 100 miles an hour." If someone called you at hour 7 and asked you how fast are you driving, you would say, "Hey, I'm driving 60 miles an hour." At no point during that 8-hour trip did you ever drive 80 miles an hour. Now, of course, someone might say, "Oh, well, I did drive if you went from 100 down to 60, you had to pass through 80 at some point, right?" Yeah, I mean, technically, yes. Or if you were like, "Oh, at the beginning of the trip, you were going from 0 to 100, so you had to pass 80 at some point then, right?" Yeah, I mean, yeah, you do. But for our hypothetical example here, we're going to assume that you were always going 100 and then you were always going 60. Let's forget about, that quick jump you made between 100 down to 60. So for all intensive purposes, you were never driving 80 miles an hour during this 8-hour trip. You were always driving either 100 or you were always driving 60. But your average rate of change value says you were driving 80 miles an hour for the entire trip. So that's what you're doing whenever you're finding the average rate of change on a graph. Like in this example, you're finding the average rate of change of y equals x cubed between 0 and 1. So the value that you come up with doesn't necessarily mean that the graph is changing at that rate. It just says that over that interval, that's the average amount that the graph changes. So the way you're going to calculate that is through this little formula here on the right part of your screen. So this is f of b minus f of a over b minus a. So you're going to take the right endpoint, the value of the function there, subtract it from the left endpoint, the value of the function there, and then subtract b minus a. So for the example we have here, f of b is going to be f of 1, f of a would be f of 0, b is 1, and a is 0. So I've done the calculation for us. It's right here. So for this example we have, it would be f of 1 minus f of 0 over 1 minus 0. f of 1 is 1, f of 0 is 0. So it's just 1 minus 0 over 1 minus 0, which is 1. And what this value tells you is that in this section of the graph, on average, you change 1, you go up 1 for every unit you go to the right 1. So another way to say that is that, another way to look at that, I should say, is through a linear line. And ooh, that is not a good looking linear line, but so again, remember a long time ago whenever you calculated slope, you learned that slope was rise over run. So what this 1 value right here is telling you is it's assuming that in this section of the graph of y equals x cubed, that for every 1 you go over, you go up 1, which is the same thing as having a linear line. It's the same as having like this. It's the same as the slope of y equals x. It's the same thing. So another way that you can calculate average rate of change is by creating a linear line between these 2 points, and then just doing what you always did in middle school and in high school, is just using this. Just using this change in y over change in x formula. This change in y over change in x is the exact same thing as f of b minus f of a over b minus a. Those two are equivalent. You may have never really used f of b minus f of a over b minus a. You may have always seen this change in y over change in x formula, but these are both the exact same thing. So either way, whichever one you can remember better, whichever one makes more sense to you, use that, because they're both the same. But fundamentally, this is all you're doing whenever you're finding average rate of change. And you can do this with any point. So, we could take a different point here. I'm not actually going to calculate it, but just because there are going to be some weird numbers, because we don't have any more, like this is 0, 0, and this is 1, 1. We don't have any more of those on this graph. But let's just say we were taking, this point right here and this point right here. All you have to do is plug in f of this point, which this looks like it's, 1.7 or 1.8. It's a weird value, but you would take f of this point minus f of this point over this x value minus this x value, and that would give you a result that would be the average rate of change for this section of the graph. And again, another way that you can think about that is all you're doing, and this, excuse me for this ugly line that I'm about to draw, but it's not even close to being a linear line, but you just connect those 2 points with a linear line, and you find the slope of that linear line, and it's the same thing. So either way gets you the same answer, and both of those represent the average rate of change of the function in that interval.